Okay, question 3. We've got a city building. The internal temperature is essentially controlled. This temperature, T in degrees Celsius in time T hour, is given by the function where T equals all of that. Where T corresponds to midnight on Sunday and T equal to A corresponds to midnight Friday. So that's going to help our domain, isn't it? So if midnight Sunday to midnight Friday, how many days is that? That's midnight Monday, Tuesday, Wednesday, Thursday, Friday. So that's 5 full days. So that's going to be 120 hours. So let's define our function. Again, f1 of x equals, go with a 2.5 times sine this time. Times sine of pi on 12. So let's just manipulate that. Pi on 12. Another advantage is it's in terms of x, so I don't mistakenly put t. So I've got x minus 6, close bracket, plus 20. And I reckon it's going to be between 0 and 120 this time. So there's my function. Right, so the amplitude, obviously there, 2.5. What is the temperature inside the building at midnight on Sunday? So what's that? Midnight on Sunday is 0 hours gone, so F1 of 0. Temperature is 17.5 degrees. At 10 a.m. on Tuesday, so 24 hours is 10 a.m. Sorry, 24 hours is midnight Monday plus another 10 hours, so that's 34, isn't it? So F1 of 34, 22.16 degrees, or 17, get the rounding correct. All right, so what are we doing next? What is the period of the temperature function? So the period is going to be, it's equal to 2 times pi over pi on 12, which is 24, so the period of the graph is 24. Right, find the maximum temperature inside the building during the week. So this might be a good time to go to our graph. So we've got a lot of stuff in here that we don't want, more than likely. So let's go to tab. Oh, excuse me, sorry boys. Let's just get rid of that. We don't want that line on there. Tab 2.5 sine x, that looks about right. Enter. I guess only slight downside, maybe we could open up a new, there's all my points of intersection or whatnot. So let's get a window that suits, sorry. Menu, window zoom, window settings. We just decided that -1, 120, wasn't it? So we'll go 125. What are my temperatures going to be? So again, sine and cosine is 1, so we get 20 plus a bit, 20 minus a bit. So what if we go down to maybe as low as 15 and maybe as high as 30? There's my graph. Okay, so let's analyse the graph again. Geez, we've done this already a couple of times. The maximum value, again, fortunately, nice values, 12.25. Analyse the graph maximum. Analyse the graph max. So notice the difference, 12, 36, 60. So it's every 24, isn't it? Every period. Analyse the graph max. Analyse the graph max. So there's all our, maybe just slide some of them up out the way a little bit. So yeah. And let's analyse the graph minimum. Now we already checked the 0, 1, didn't we, when we said f of 0, which was at 17.5. Whoops. So let's analyse the graph minimum. We know it's at 17.5. they're nice values. Again, because they're exact numbers, I'm happy with just analyse the graph. If it was 24.1367 or something, I'd have to solve. Okay, I might go back in here and go solve f1 of x equal to 17.5 for x. Okay, and we get our answers. Now, because when I defined my function, the key thing to remember, because I defined my function up here, and I put the 0 to 120 in already, it means I get exact answers straight away. All right, so I don't have to worry about 0, 24, 48. So I know roughly 0, 24, 48. So in reality, I can just put those values straight onto my calculator. The endpoint is at 120. So I could possibly go in here and just do F1 of 120, 17.5, so that's good. So I could put all those values in. So now I've got my graph. The question is, the maximum temperature inside the building during the week is 22.5 degrees. The minimum temperature inside the building during the week, 17.5 degrees. What is the average temperature inside the building? So don't forget the average is the middle line, the line across the middle. So it's halfway between 22 and 17.5. So if you wanted to work it out, 17.5 plus 22.5, was it? Can't remember. Plus 22.5 equals, divided by 2. So my average temperature is 20. And if on my graph, I just wanted to put 20 in, I can see that that's sort of straight through the middle, isn't it? So that's my average value. All right, find the value of A. Well, we spoke about that already. A is the last value on the 5th day, so it's going to be 120 hours. Sketch the function just between 0 and 36 on the axis below. Well, that's a bit easier for us. Is it the same graph? Looks like a different rule, does it? Oh no, it's the same rule. Coordinates of any endpoints and turning points. So maybe, just to confirm things, there's our graph up here. Let's just change that back to 36. Okay, so that's where my graph ends. So what is that endpoint? It looks like it's a maximum. Analyze graph at the maximum endpoint. I want to do this graph. It is, okay? So that's the graph that I'm drawing. I'll get that first endpoint in at 0. Yeah, 17.5, so that's where I'm putting it in. Endpoints, turning points clearly labelled, okay? Straight off the calculator, so that's good. End of question, all right? So again, geez, if you can work your calculator well, it's just really then interpreting. So you've got to practice these calculator skills.